Hello and welcome to this exercise on sector, perimeter, area, radians, degrees. It is from a past exam paper and is suitable for iGCSE, GCSE or additional maths. Now we've been given this little drawing of a sector which is part of a badge, by the way, and we're told that the triangle CAB is an equilateral triangle. That being the case, CB will be the same as CA and equal to AB. So that's R. We're told that the vertical height is 3 centimeters, and we're supposed to find the length of CB. In other words, to find the radius of the whole circle in terms or in set form or radical form. Secondly, we're supposed to find in terms of pi the area of the whole sector there. And thirdly, we're supposed to prove that the perimeter is 2√3/3 times pi plus 6 centimeters. Okay, now for the first section, because this is a vertical height and this is an equilateral triangle, so the vertical height will divide the triangle into 2 equal sections, equal and similar. So from there to there will be half R. Okay, now we deal with Pythagoras now. So R squared is now 9 plus half R all squared. Now half squared is a quarter, so R squared then becomes 9 plus 1/4 R squared. If we then move 1/4 R squared to the left hand side and isolate R squared, we have that R squared into 1 minus a quarter is equal to 9. Now 1 minus a quarter is 3/4. So we now got 3/4 R squared at the left hand side is equal to 9 on the right hand side. If we then divide both sides by 3/4, we have that R squared is equal to 9 times 4/3, which is 36/3. And that gives us R squared is 12. Now, if we then take the square root of both sides, we have that R is equal to the square root of 12, which is the square root of 4 times the square root of 3. And the square root of 4 is 2, so R is now 2√3. Now, for the second question, section B, the area of this sector, if working in radians, is half R squared theta. And it doesn't matter if working radians or in degrees, you probably get the same answer. Right. R squared theta and theta is pi/3 because the angle there is 60 degrees because it's an equilateral triangle. So we then end up with A is equal to a half from there. Now R squared we know is because R is 2√3, and if you square that you should get 12 there. So the area is a half times 12 times pi/3. Now 2 times 3 is 6, 12/6 is 2. So the answer is then 2 pi. Or if you wish, you can do it using degrees. You can say that the area is 60/360, 60 because this is an equilateral triangle. So 60/360 is a half, sorry, it's 1/6 times pi. Now 2√3 all squared is 12. So we now have 12 divided by 6, and that's 2. So the answer will be 2 pi, as we got earlier. And now for the third section, we're asked to prove that the perimeter is 2√3/3 times bracket open pi plus 6 bracket close centimeters. Now the perimeter is L. L is the arc length plus radius plus radius. So it's P is equal to L plus 2R. Now L in radians will be R theta. So it's P is equal to R theta plus 2R. Right. Now theta we know is pi over 3. So R theta then becomes R pi over 3 plus 2R. So if we then isolate R, we have that P is equal to R into pi over 3 plus 2. Now, if we then multiply 2 by 3 and divide by 3, we have that P is equal to R into pi over 3 plus 3 times 2 over 3. Now, that makes no difference at all, because if we multiply the top by 3 and the denominator by 3, that makes no difference at all. If we then isolate the 3 from the denominator, we have that R over 3 is equal to pi plus 6. And we know that from the first section that R is 2 root 3. So we then end up with 2 root 3 over 3 into pi plus 6 as required. I hope all that made some sense, and please subscribe. Thank you for watching.